a lot of chapter 8 is formalisms. Like, I should not be making you or letting you guys use the word derivatize, as that makes you sound kind of like a third grader doing calculus, which is kind of cool, but
All my
the
homies
energy
love
that I
the derivatize.
third grader doing calculus.
Anyway,
Okay.
I'm predicted.
So we are formalizing the end-to-the-end people rationale. We are also getting into pre-chapter 9. Like, this is chapter 9 light. There are techniques in here that we'll use throughout chapter 9.
It's time to begin living it.
Right. I do get like statistics on how my students do on the topics overall, and go figure, I get dinged on formalities, like y'all aren't very good at the notation, and chapter 8, lots of, do you have the notation right? And despite what I thought was stressing things a lot in the video and pointing out in the work, third period, a lot of people said, yeah, but we don't really have to pull out the numerator and test and the denominator and test. I'm like, oh no, you do, and I will take points off if you don't. And they're like, well, you're just kidding, right? I'm like, try me.
But something I saw was, instead of just writing L'Hopital's class, can we just write L apostrophe?
Okay, one thing you don't need to do is write that at all.
Oh, cool.
But I was trying to stress that this is what that work was doing, and L'Hopital's a class. You don't actually have to write that. You do need to write the limit of blah, blah, blah equals, and then the limit of the other part, blah, blah, blah equals. Yeah, but another thing in those statistics is my students outdo the national average on that chapter 9 question by at least a point. Like, you guys overdo. Meaning, I overteach it, I get you scared about it for 2 years, and then by the time it gets here, you guys are like, oh, that wasn't so bad. It's only run over by a car, not a whole semi. It's okay.
Nothing smushed by a plane.
Right, you know, it's just
I'm still
minor
slightly
internal
greedy.
damage. Okay, but, all right, so looking at this, first thing, a over b as x goes to infinity, that thing goes to 0. So Luke, what do I know about a or b, or do I not know anything?
You know that the degree of b is greater than the degree of a.
So it's bottom heavy. B. Go me. Ava, what about the second one? A over b as x goes to infinity, this goes to...
But it's like top heavy, so it will have wheels.
And Marco, what about the last one?
Well, I mean, okay. So, I mean, it has to approach 7, but like, I don't know how to say it.
You don't say A is 7 and B is 1.
Okay, they have to. No, because it'd be like 7x over like
X.
x. Yeah, but then that's just 7.
So, can't read my scribble. This one, the function is, the one on the bottom has more stuff, stronger, it's bigger.
Stronger base.
This one, it's top heavy. And this one, whatever the functions are, they're of equal strength. And you guys gave me the algebra 2 things. Oh, the exponent in the denominator for that polynomial is bigger, so it's bottom heavy. The exponent in the numerator is bigger, so this and the exponents are equal. Well, what we're going to do today is we're going to compare functions that aren't polynomials and reason with them. Yeah.
For 3, the coefficient would have to be 7 over 8.
Reduce to that, like 21 over 3 or whatever. Utah?
Is strength like the actual term?
No. So it's degrees of infinity. So today we're gonna use some kind of more formal math to show, like, where we would have said end to the end people, exponential stronger than log. So this is gonna happen. I'll show you a math way to prove it. And 8.2 specifically is not exactly tested. However, you will use concepts from 8.2 for you to create your own stuff. So today is just practicing a skill. So in particular, by end of the n people, if we wanted to say who grows faster, e to the x or natural log to the x, what's the answer? E to the x. And but testing, this goes to infinity, that goes to infinity. Are there really different sizes of infinity? Oh, hell yeah. So if each centimeter of this board was 1 unit, and I did natural log of this many centimeters, it would still be on the board. E to the x, doing that, it would be most of the way to the moon. Like, it is that significantly different. This one's still on board, that one's astronomical, okay? But a way to prove this, Peter, you pick which. I'm gonna make a fraction out of these. Do I want e to the x on the top or natural log on the top?
Let's do e to the x.
Okay, e to the x on the top. Perfect. So comparing that, and to formalize our L'Hopital's business, I'm going to test the numerator. At infinity, e to the infinity is huge. And natural log of infinity, it gets there eventually. So our does L'Hopital's flat.
Yes.
Yes. Okay. So Akira, what is the derivative of the numerator? And Hunter, what is the derivative of the denominator?
1 over x.
1 over x. And I don't like the fractions like this, so I'm going to multiply by x over x. Then Charlotte, I get x e to the x over 1. Where does that go as x goes to infinity? Infinity. So this was not a polynomial over a polynomial where I could compare the degrees, but I got, when I checked these two fractions one over the other, this came out to infinity. So does that mean it's top heavy, bottom heavy, or are they equal?
Top heavy.
Top heavy. So here you've just proven that e to the x grows faster, significantly faster than natural log of x. That is the formalism of n to the n people. And Utah, the official wording is e to the x grows faster. All right, so there's our first example. This one is a little bit different. Josh, what do I need to set up to see what's going on?
Limit expression of infinity for each one.
Well, not yet.
Oh, you want to divide them?
I'm gonna do this, and now if I pull them apart and I do L'Hopital's, e to the x is e to the x is e to the x. And unfortunately, 3 to the x is 3 to the x, 3 to the x, with some natural log of 3, some constant that keeps popping up. So L'Hopital's is not gonna work here, because I'm just gonna keep spinning in a circle. No? Do what? Well, that's not gonna help me either. Tanya?
Isn't it like 2.71 and 3 is 3, so 3 would grow faster than 2.
I love it. Isn't E like 2.7 whatever, and 3 is like, 3? Okay, yeah, so am I allowed to do this? Can I pull the common exponent off and make it this thing?
Yep.
Josh is like, well, you really want to. And then Tanya said E is a little bit smaller than 3, so is this exponential growth? Is this like 2 to the x, or is this like exponential decay, like 1/2 to the x? Decay, because this thing, this base is less than 1. Right? Y equals 2 to the x. If the population is doubling each time, it's going to get huge. And y equals some number less than 1. You get half the population each time, or you have this many M&Ms and you ate the ones that when you rolled them, the M's came up and you eat them, then you roll them again. Did you guys do that experiment in like 5th grade? It gets disgusting
Sounds
because
tasty.
you guys like hold the M&Ms
Oh yeah,
and
they're
they're
all
all
over
melty.
your hands. Like
And-
the colors.
And like I stopped doing it because I'm like, look, I have a whole bag of clean M&Ms. You can eat the clean ones later, but don't eat the ones you roll and they're it's disgusting.
So that with Kit Kats and stuff. Even like cup
It doesn't. No, it doesn't.
Do
No.
Reese's
It's
peanut
you know
butter
it's generally
cups.
better because
It
you just
needs.
cup
They
them.
need to be able to quote roll.
You know.
Can't do that. Anyway, so right here, this goes to 0 because it was exponential decay. Why was it decay? Because e over 3 is less than 1. So is it top heavy, bottom heavy, or equal? Bottom heavy, which means grows faster, that 3 to the x. And the end of the n people would have been hard to do with this one because it's e to the x and e to the or 3 to the x. They're both exponentials. Yeah,
In the end of the end, people, what does end of the end stand for?
it is literally n to the n. 6 to the 6, 7 to the 7, 8 to the 8, 9 to the 9.
So is it like x to the x? Or?
N to the n, x to the x. Number 2 exactly itself.
Okay, and that grows the
The most
fastest.
powerful,
Really, really much so. Yeah.
the most powerful.
But the only function that works for that is x to the x, right? Because the other ones are just constant.
Yeah.
Yeah.
Um, and even in chapter 9, we don't get a lot of n to the n. We get factorial like all over the place, just littered everywhere. But no n to the n's. But fecal doesn't just doesn't have that. Fecal sounds fecal. It's just not a good. It needs something. All right. Next page. Let's go. Okay, crazy business.
Oh, do we have to do the thing where you raise it to the e to the thing, e to the not?
Why?
No.
No, you don't.
Oh,
How am I gonna check? Lucas?
You can set up the limit as x goes to infinity of 6x squared ln minus ln over. Just-
oh, it says or two, right? Okay.
Oh yeah.
Okay. Can I just do pre-cal and be like, yo, I know what's going on?
Yes. Sure.
Yes? Well, in pre-cal, did we ever have natural log of x in our things? No. So we're gonna do the test to see if L'Hopital's works. Oh, you know what? I'm gonna change this. Make it a plus. Someone else in 3rd grade made a comment, and I'm like, you're right.
Let's say it was minus though, would it still go to infinity? Because like since ln x is a smaller. infinity,
Yes,
that's
because,
just-
yeah,
But then
But
you have
then-
to prove that like 6x.
then you have to
squared
prove
is-
that in itself, and I didn't want to do that. So we're gonna just make it a plus.
Got the limits inside your guns.
Hunter?
That was the same question where you have to prove that 6x over 2 approaches faster than ln x if
Wait.
it was minus.
Yeah, so I don't wanna do that. This is gonna be tedious enough as it is. I get infinity over infinity, and again, you don't need to say L'Hopital's applies. You need to do this part. You don't need to say it applies, but just to stress to you that you need to test that it does work. I've been writing that. Okay. Derivative of the top. 12x plus 1 over x over 6x squared. And then here, just to clean things up a little, I'm going to multiply by x over x. Does this look like the pre-cal rational functions we did last year?
Yeah.
This one does. So I'm okay with you stopping here and being like, well, pre-cal happened. Is it top heavy, bottom heavy, or are they equal? Bottom heavy. So this is going to go to 0. So the equation that was on the bottom is the one that grows fastest.
Does that
So
actually matter which one we put on top of that one?
No, if you had them upside down, this would have gone to infinity. So it's gonna be top heavy, and the top one would have gone to, oh, it still works.
Wonderful.
Splendiferous. Not a word.
Why not?
I thought they had it.
Shakespeare invented next words,
He did,
so we can't do.
and Dr. Seuss invented a number of words. That's where nerd comes from.
Anyone can invent a word, it's just a question if there's probably people that recognize it.
You can verbify anything.
That's a obvious remark right there.
I don't know that verbify is a word, but I say it every year.
Obvious remark.
Okay,
If enough of us say derivatives, it'll be-
yes.
This enables me to create the Mixicling dreamscape.
All right. But to stress this on your test on chapter 8 that is going to eventually come after you personally, Marty.
Yeah, Marty,
It's
an elaborate.
This was not a thing we did in pre-cal, so you need to do the L'Hopital's thing. We eventually got polynomial function over polynomial function. That's pre-cal. I'm not gonna make you do L'Hopital's 2 more times to be like, okay, I get infinity over infinity. I'm gonna do the derivative again and then again and again. But while there's a trig function or something, natural log, you need to keep going. Question?
For the last step, if you had to do it further, could you split up the fraction and then plug in values?
Sure. So could we split up the function, doing more just algebra so that we don't have to do L'Hopital's? Sure.
But what fun is that?
Yeah, what fun is that? Wimps. Okay, what about this one?
Oh, God.
Natural log or log square root of x?
There's supposed to be a base of that.
No.
Base 10, no? Yeah, wait, no, default log is just base 10.
Default is base 10, it's not specified, it isn't specified, so
Base 10.
base 10.
Wait, can we just say that since it's ln is base e and then e is less than 10?
But you gotta take into account square root.
Yeah, but does it make a difference?
Does it? I don't know. Use your math to find out.
Wait, if we just make the square root into a power, so to the 1/2, and we just move it to the front. This is the 1/2.
Okay. So Marco says this becomes 1/2 log x. Okay. Now what? So can we just assume thing, you need to prove it once, and if you prove it, then we'll talk. Yeah, okay, how do you do the derivative?
We looked at it for a second. I forgot.
Yeah, we did, and I said, you don't have to
You do
memorize this
ln
because
ln x over ln.
change of base? Okay, well, how does log x change of base?
ln 10 over ln x. ln x.
Is it ln 10 over ln x or ln x over
ln x.
ln x?
ln x over ln.
Base goes in the basement. Okay, so you guys took all the fun out of it. That guy divided by this guy, now that we've done a bunch of algebra to it. I didn't have to use any calculus at all. The natural log of x on the top and the bottom canceled, and it comes out to 2 natural log of 10. What does that mean?
Same.
Same base.
Grows
Same rate.
at the same rate. They go off to infinity together, holding hands at 2 natural log of 10 apart.
That's
Yeah.
very
So what if like these functions like don't overlap, or just like exact copies of each other, so what if one like go faster than another? At some point.
I just showed that they, at infinity, are effectively
Oh, so it's
that
not
far.
about what's in the middle, just at the end.
At the end of time, like, that, yeah, all right.
But that's what they do.
This is about end behavior. At the end of time, like, if this global warming problem is modeled with this, are we going to be able to, like, contain the problem or not? Is this going to be understandable or no? What is the end behavior, not the squishy stuff in the middle? Hunter?
Mr. Weber, like, if you could do it without changing the base and just do like the derivatives.
You could. And the way I taught you guys to do the derivative of log base 10 was to not memorize their formula, but to do change of base, which still gives you. So the derivative of this is natural log of the base of the stuff inside, then multiply by the derivative of the stuff inside.
The root x is not inside the natural log.
No. So this becomes 1 over 2x natural log of 10. Because root x times root x, what comes out?
Oh, I hate it.
So, Hunter, it gives you the same answer.
Okay.
And almost the same word. Okay. Here's the fancy one.
Am I allowed to write no thanks on a special AP? Nothing's stopping.
Right, you can write anything you want. As I said, I've gotten poems and lyrics to songs, creative drawings.
What song was it?
There was some Pink Floyd on the last test. It's like, that's very retro of you.
It's not that right.
It totally is.
No.
They are of the 70s, my friend, and the 80s.
Yeah.
Yeah, but it's kind of like one of those things where
Yeah.
it's like the way that like Mozart would be retro. Yeah, it's really
Yeah,
old.
Mozart's retro.
But like
retro.
like everyone ends up hearing it a lot just because it's
There has to be a different way. There's so much.
You can factor out limits. You can take x out when you execute this too.
That just makes the product.
Yeah. You would erase it.
I got this.
No, right. There you go.
Okay, you wanna what?
I just want to take the square root of x to the fourth plus square root of 2x. That just seems like a good option.
So in the land of end people, we would say that 2x is really unimportant as we go off to infinity. So it's x squared over the square root of x to the fourth. So, it's basically kind of the same. I want to show you like math for why you can still reason this. Do you agree that the square root of x squared is x squared?
Yes.
Okay, so this is x to the fourth on the top. This is x to the fourth plus 2x. And I am allowed to push that limit inside the square root. And now, using pre-cal, hey, that goes to 1. Square root of that is 1. So effectively, Arjun, it is the same thing. But this is like, if you had to spell out math to support, be like, here you go. Ha! right?
What? Huh?
I agree, huh?
Marco is completely confused. Okay? So again, this specific unit is not, or section won't be on the test, but you will find yourself in a day or two picking two functions yourself and doing this limit comparison thing. So, questions from the L'Hopital's homework? Yes?
47.
47. Again,
47 was really good.
47 was fun.
It was
We also do 39.
Yeah,
47 was fun.
47 was fun once I figured it out.
I
I never
couldn't figure it out.
I don't
Well- Okay. So 47 is saying this is effectively a removable discontinuity. What's the y value? So it's really asking you to do the limit as x approaches 0 of this thing. In third period, we tried splitting it up and we got an undefined minus another kind of undefined, and it didn't go well. So because of the specific unit we're in, what do you think we need to do? The hospital, yes. When you get one of these crazy trying to divide by 0 things, send it to the hospital.
I mean, isn't sin x kind of like bounded? So
Okay, well, hang on. So plug it in 0. I get 0 minus 3 times 0. That's 0. And the denominator, yes, as stupid and trivial as it seems, you need to plug that in. Top goes to 0, the bottom goes to 0. 0 divided by 0? Okay. L'Hopital's applies, so derivative of the top, 9 minus 9 cosine 3x over 15x squared. Derivative of negative sine 3x is positive, is negative cosine 3x. So, all right. Now plugging in 0.
0 over 0.
Do you have to show that you would plug it in again?
You need to do this again, yes, because you want to do L'Hopital's again. We get 9 minus 9, which is 0. And in the bottom, we get 0. All right. Again. Mateo, what's the derivative of the numerator?
That would be negative 27 sin 3x.
Just
Or sorry, 27.
Positive?
27.
Utah, what's the derivative of the denominator? 30x. Okay.
Oh boy.
One more.
Here we go again.
Getting a sense of deja vu.
Yeah, it's all over again.
Groundhog Day equation.
And so we okay. We'll be official about it a third time because this is great fun. That goes to 0. That goes to 0. Marty, what is the derivative of the numerator?
That's going to be 81 cosine 3x.
And the denominator is just 30. So we get, today, 0 divided by 0 is 27 over 10. Take that, L'Hopital. Yes. Okay,
Now the actual sum of all real numbers is purple.
and we do the square root of Texas already.
It's 42. That's the
Um,
answer. That's why.
well, like either or something.
these kinds of problems,
Ian.
yes, well,
E to the ln.
E to the ln of that limit. How can you tell that that's what you gotta do? Lucas?
Because it's like raised to the variable x.
Variables to a variable, moving target, moving target. Do we need to do any of those? Yeah.
I was kind of confused on 39. Like, I know how to get there, but like they did some like manipulation of sine and cosine that I didn't understand.
Thank you for not taking 35. I had to do that one earlier today. 0 out of 5 stars, do not recommend.
That was fine. It's just one.
It was just a,
I'll just cross it out.
Here's what I get. Like, I'm just
Okay.
what's it about? I look into the notebook.
Zero.
I just got one.
It is one.
okay, so we're doing E and ln at the same time. They are inverses of each other. And the reason we're doing that is I'm gonna take this stuff apart. And I'm gonna move the limit outside and the natural log inside. Because I can. Ethan, what can I do with this now?
Could you move the x to the front?
Sure can. Move the x down here. Does L'Hopital's apply? No, not yet. Isabel, what do I have to do? I gotta use the trick that I mentioned in the videos, which was force L'Hopital's to apply, because right now this is 0 times negative infinity. Do you guys realize that? 0 from the right, sine approaches 0 from the right, goes to more and more from the positive side. So it's natural log of really, really, really close to 0, which is really, really, really negative infinity. All right, we get natural log of sine x over 1 over x. What do I need to do now?
Relation.
Then you test things.
Test the numerator and the denominator. Oops. And this is, so the sidedness of the 0 matters in this one. 1 over x as x goes to infinity, or 0 from the right is positive infinity. Utah, is it okay that it's a positive infinity on one side and negative infinity on the other? Yeah, that's okay? All right,
You can hospitalize it.
we can hospitalize it. Okay. So how do we hospitalize it? And please don't write that on your AP exam.
And the function
This
is
is how we
hospitalized.
break
So you
down
do
your
like
string
proof and
drag.
instead of writing L'Hopital's applies, you
This
write
is-
function may be
This is
hospitalized.
why
This is
they-
why they won't let you on
Sign it,
calculate
sign it.
chat. It's because they already know we're gonna write, like we're gonna hospitalize the limit.
You're getting
We're gonna
points.
hospitalize to
That's your
derivatize.
limit right there.
Yes, and now I shall send this limit to the hospital to receive emergency care.
That too.
Derivatives.
Sorry,
So-
it's always the way to fail.
So Utah, what's the, what do I get? We're L'Hopital in this dude.
So you get ln sine x becomes, so you get 1 over sine x times cosine x becomes cosine x over negative 1 over x squared.
Okay, this one's a pain. Derivative of the natural log of stuff is 1 over stuff times derivative of stuff, so we got cotangent. And then this guy, universally the most incorrectly derivatized thing, multiply by the power, lower the power. You either drop the negative or you add 1 to it and you call it natural log of, I don't know, you go the wrong way. But we get this. As we approach 0 from the right. What now? Are you?
Can you just like put the x squared on top?
we get negative x squared cosine x over sine x. So we didn't L'Hopital's or anything like that.
This is where I get confused.
Okay. Because now plugging in, Peter?
Can't you just change it to cotangent x and then realize that what you're doing is multiplying cotangent x by 0 when you do the limit? Which means that your answer is just going to be e to the 0.
Cotangent, you're going to have 0. Like if you do that, you're going to have 0 times infinity, which is one of our indeterminate forms.
Oh, it's not just 0 by a thing. Okay.
Right. So there are a couple options. Do L'Hopital's again.
Send it back to me.
Yeah,
Really?
we can do that. 1 times 0 is 0. And sine x. That's 0. Do the derivatives and go there. And from the very beginning of the year, like day 2 when we finally started calculus, we did something with this.
Oh.
What is that? 1. So now over here, what do we get? 0. Is my answer 0?
No.
E to the 0.
1.
All the way up here that was scrolled off.
Should we be keeping the E with it or just like bring it back?
I do different things each year, and
Does it matter for the exam?
no, it doesn't matter. You can. It matters if you forget to bring it back. And some years I drag it around each time, and I have noticed 0 difference in those of you that forget and don't forget. So. But there you go. That's that style of question when it's a moving target to a moving target. You need to do E and ln from the beginning, and then move the log in, pull that exponent down, and then force L'Hopital's to work somehow. Cool. Other questions from these? Any? I posted an optional L'Hopital's on Delta Math if you wanted more practice with these with instant feedback or videos. Remember there are videos on there. And stuff. Yeah.
Can you do 35?
Just when you thought you were safe.
Pascal.
Could just do algebra at some point.
There are only 2 minutes left. Do it with some speed.
Yeah, these are not these are not speeding.
Oh my god, I hated doing so much. So much stuff to write.
Right, so the first step is plug it directly
Yeah,
into the
well,
calculator.
You really know what to do, then it's like, man.
You know, Jesus does this for us.
Yeah, it's like-
When has he done that? Real talk.
My favorite part of the Bible is when Jesus.
Okay,
started doing
okay.
calculus.
Yeah.
So if there really is 2 minutes, shush. So E and ln, I'm skipping some steps. I moved natural log in, I pulled that exponent down and moved the limit out. Here I get 0 times negative infinity. L'Hopital's does not apply. So we're going to do the trick that Isabel said to do earlier. And here, Marty, I'll keep the whole damn thing together.
Thank you.
And now testing the numerator at, and they need, the textbook didn't write it, but it needs to be a 1 from the right. Because that one, it is just undefined. 1 from the right. That goes to negative infinity. And this guy, 1 from the right, goes to positive infinity. Doing the derivative. It comes out, skipping oodles of steps. So Ava, this thing actually factors x minus 1 squared.
Well, because what I was doing, I just put in 1, and then I later, I think it was like 0. Oh wait, I thought that was, yeah.
Also, just could be that you.
Like when you're thinking of the limits, can I just,
Does something ever go down to 25?
For us, it's really, really rare, but if it comes down to, I got 1 over 0, then it is straight up just under.
So it can
It can, if it does, I would double check my work.
Okay.